Zoom it. So if you ever need to know what we're doing each day, I wouldn't touch that. You go to the daily plan. So December 3rd is tomorrow, but today, December 2nd, I hate that YouTube chose my beautiful gut is the whatever. And I changed it, but when you paste it in to Canvas, it just stays as the original one it chose no matter what you do. Okay, today we will cover the Saga lab on page 3. It will help us learn how the reactivity of nonmetals changes as we move along the periodic table. Okay, so we have this so far. All right, staircase. We had this and this. What we're going to figure out are the arrows that go here. That's all we're doing. Easy enough. Okay, the Saga lab is the easiest lab of the year, in my opinion. If you screw this up, then you have issues. Oh, I didn't cut the, oh, it's on the instructions. So you have this data table right here. What you are going to do when you come back to your station, you'll have a block full of pipettes. Let's see. Sure. All right, so you have a block full of pipettes. Most of the liquids, I should say, are right by Savannah, right in front of her. But I thought they were talking, but it's a safety video. The bleach and the hydrochloric acid are in the fume hood. Okay, but the rest of them will be right there where Savannah's sitting. Okay, now this is, like I said, the easiest lab of the year to not screw up. You will need one of these, that's all right, instruction sheets. On the instruction sheet, it has this circle, and then it has other circles. What you do is you take your Petri dish and you put it on that piece of paper. And then there was something in that Petri dish. That was gross feeling. All right, then you just put the drops right there, just how it shows you. Easy enough. Now in the center, it says bleach. So you'll put some bleach, and you'll do this on a table, obviously. You'll have the bleach, and then the instructions tell you to put hydrochloric acid in it. Now, that is extremely dangerous. That produces a gas that can kill you. So what you should do as soon as you put that in is you're going to put the lid on it. Now, we're not going to make that much gas that it will make anyone even sick or damage you at all. It will just smell like a swimming pool in here. But don't ever in your real life mix bleach and any sort of acid. That produces gases that can kill you. And people really, each year, they die in their shower because they did exactly that thing. They'll like scrub something and it's not working, so they go and switch cleaners, and then they spray it, and they don't know, but they've just created chlorine gas, which will kill them because they're just in their small little shower. It fills up that environment. So, oh, I'm really zoomed in. So don't ever mix chemicals in the bathroom, in the shower, in the toilet, in the kitchen. If you're going to ever use more than one chemical, completely rinse the first one off before you do the second one. That's your safety hazard. Okay, now for this lab, what we're trying to do is we're trying to make chlorine gas so we can see what chlorine will react with. And if it reacts with something, then it is more reactive than that thing. Just kind of go with me for a second. So here's a picture of your Petri dish. And you'll have all these blobs. And then you'll have a big blob in the middle. And we've produced chlorine gas. And its formula is Cl2. And the G just means it's gas. And these droplets, they'll have like sodium iodide. This is your bleach, whatever. And then like sodium bromide. And there's more. But what will happen is the chlorine gas, it will go to the droplet. And if chlorine is more reactive than iodine, then the droplet will change color. That's all we're looking for. So you'll put that lid on, you'll watch for 3 or 4 minutes. Some of the droplets will change color. And if they change color, then chlorine is more reactive than this part. We don't care about the metal. They're all paired with a family 1 metal. We know the rules there. We're studying what happens to the iodide, bromide, fluoride, chloride. They're all right there. F, Cl, Br, and I. They're all in family 7. Okay, so one more time. If the droplet changes colors, then chlorine is more reactive than the thing that changed color. If it doesn't, then chlorine is less reactive. Okay, this doesn't take super long. There are instructions. There's the instruction sheet right there. When you fill all these up, you can leave them for next hour. You don't need to empty them. Honestly, filling them up once all day is good enough. When you're done with this, just take the lid off and wash it. Don't turn the water on very high. It will spill everywhere. So just dump it and then rinse it. It's really easy. That's all you have to do. And once again, what we're trying to figure out is how the reactivity, this lab only shows you the up and down, how reactivity changes up and down for non-metals. Okay, safety glasses, same routine. You have to have them for sure. If you have your own glasses, I forgot to say that yesterday, you can wear your own glasses. That's fine. The instruction sheets are right over where Tyler was sitting. All right. So based on our data, draw a little periodic table right here. Put an arrow either pointing up or pointing down, which way you think the reactivity trend goes. So far, 0 for 2, even tried it. All right, right here, there should be an arrow based on your data. See if you can get that. Interesting, we have quite the debate here. Okay. All right. I only saw 2 people with the correct answer.
So it is up.
It is up. Let's go. Good job. Let's talk about why it's up and the data that supports that it should be an arrow pointing up. Right. So this was clear. This was clear, 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 whatever. Blue or green, probably. And then clear. And then this one goes yellow, yellow, clear, red maybe, whatever. Blood orange. Okay. All right. And then I'm right in your way. Sorry. Then this stayed clear. This changed. This was just to see if the reaction was happening and like if it was done. So we don't get that. And then this goes yellowish also. Or brown or bronze, whatever you want to call it. Okay, so from the start, anything that changed, chlorine was more reactive than. So this would mean if I put these on the periodic table, I have Br, I have iodine, I have chlorine, and I have fluorine. The 2 things that changed were right here, and chlorine was more reactive than them. Now, chlorine just stayed clear, so that's really not data. If chlorine reacted with chlorine, it would just be chlorine. But we can learn something from fluoride. We learned that chlorine did not have the ability to kick fluoride out of the party. So fluoride would be more, I should say fluorine, sorry. Fluorine is more reactive than chlorine, and chlorine is more reactive than bromine or iodine. So there is our arrow. All right. Blake, are you doing all right? Okay. So did I when I was your age. Okay, now I do not have a lab that teaches the side to side. So I assure you, as we go to the right, we get more reactive. And that's kind of, I mean, we have carbon versus fluorine. We are made out of carbon. Most of the stuff you're sitting on is made out of carbon. A lot of the stuff you're looking at is made out of carbon. It's pretty non-reactive versus fluorine, which is the most reactive element of all. All right, so on our periodic tables, the big one that you labeled, the one you colored, make sure you have that. Who needs a new one? Anybody? Well, that's convenient. It's right next to you. All right. So we colored one first trimester. On that side now, please add your reactivity. Oh, you need one? Yes, Cohen. Yeah, we do not include noble gases. So that arrow, we're going to put it in family 7. Noble gases just don't react. So there, we don't include that arrow. Nope. Okay. So you don't have 2 colors. I mean, if you want, you can. But you need to know for metals, it's lower and lefter. We all right with that? Lower and lefter, the more reactive. Then for nonmetals, excluding family 8, it is the higher and righter. Now, I know lefter and righter are not words. Yep. There you go. Yep. Okay. So add those somewhere because you can use this on your exam, and the test is really, really simple as long as you have the periodic table. So let's practice how this will look. It'll say something like Cu and vanadium. And it will ask you which one is more reactive. And you would say vanadium. And you know it because the arrow says the lefter I go, the more reactive it is. All right, it could say copper and gold. And even though this is not true, generally speaking, as we go lower, they're more reactive. So you would say, all right, gold would be more reactive. Now, in real life, it isn't. There's lots of discontinuities on the periodic table, but generally lower left or higher righter. Go ahead. Yep, and I would never ask you copper and gold because really they're not reactive at all. It was a really dumb thing to write on the screen. I apologize to everyone that was offended. All right, so let's look at your homework and just answer the first 10 questions. Well, it might be the first, yeah, first 10 questions, I think. And then 40, not 36, kids. I'm going to remember today. There's a clock on the wall. Oh, that is unfortunate. All right, so Page number 14 probably, or 16 probably. 15? You're right. Okay, look at page number 15. And then look at 7, 8, 9, and 10 first, because I realized we didn't do something yesterday that we need to do. So look at 7, 8, 9, and 10 and try those while I try and find this other thing. Oh boy. So use those arrows. Yeah, that's not what I wanted. It's going to take me a while to find this. Oh my, come on, computer. Okay, this is what I'm looking for. All right. 7, 8, 9, and 10. Oh, well, lower left or higher right, or then you can use that one right there to find the symbols. Okay, so the first one, number 7, would BE be more or less reactive than BA? So we have BE right here. And then we have BA right there. Ignore strontium. Can't delete that part. So I forgot how it was worded again. Would BE be more or less? Tell your partner. It would be less. Good answer. The one that's higher is less reactive. All right. Then there's more. But I forgot we were supposed to do this as part of yesterday's lab. All right, so look at this periodic table that you have. This is the one that has what we call the electronegativities on it. Okay, turn to this side, and we're going to label these things. We're going to label these things. Now, you have data right here. Don't write this stuff right there. Write it up top. So these things right here, just to be super clear, whoops, these, you're going to write them like in this key area, not there on the right. Okay, so let me explain what we're looking at. This is the stuff that'll help you on the test that we learned in yesterday's lab when we added hot water, cold water, and acid, and these metals. So in lithium, in that box, put a small little CHWA. And then you have two options. You can put an arrow, or you can put CHWA in every single box in family 1. It does not matter to me. Everything in family 1 reacts with cold water, hot water, and acid. That's what CHWA means. It means it will react with all 3 of these things: cold water, hot water, and acid. Now, in family 2, we had beryllium and magnesium will only react with hot water and acid. They're less reactive, so we have to add hot water. They won't react with cold water very well. But calcium, strontium, and barium and radium, which we wouldn't do, also react with cold, hot water and acid. Are you with me? Because this is a section on the test. It's extremely simple unless you are standing over there not filling out your periodic table. You're just going to memorize it? Oh. What? Okay. All right. Next, AO for all of aluminum and lower. AO means they react with acids only. So they're even less reactive than the first two columns. I have to have acid, and really I have to have concentrated acid to get it to react. And then the rest of the metal families right here, NR means no reaction. So if I put bismuth in hot water, cold water, or acid, it wouldn't matter. It won't react at all. Okay. If you want, you could add your arrows here for reactivity as well. It doesn't really matter, but make sure you can read all the stuff on there. All right. That's going to be blocked for just a second while I cut this other thing, but I promise I'll bring it right back. If you guys, just real quick, if we ever start a new lab book, like while you're quarantined or at home, you can find a digital version of your lab book at the top of each module. So like if you open this Bonded for Life lab book, the top thing is just a PDF if you want to print that out, or you can just have it and like write all this stuff on paper. It's up to you. Anyway, let me cut some of the homework out so we can look through it. Some of you might still need that, so. All right. Just realized I'm muted. Okay, so let's combine what we just did for questions 1 through 6. So, and it really is this easy on the test. I hope you're comfortable with this. It says, for each of the following, use one of the following phrases to describe their reactivity, and it asks about strontium. So you go to your table and you find SR. It's right here. It's in the CHWA, which means it reacts with everything, pretty much. So I'm going to go back to my homework, and it says, A reacts with cold water and acids. That is a true statement. Reacts with strong acids only. That's not true. Reacts with hot water / steam and acids. That's kind of true, but we don't have to make it hot. It reacts with cold. Does not react with water or acid. So the most accurate statement for this is A. A is the one that means it reacts with everything. Okay. B, it reacts with like hot stuff and acids. Reacts only with acids, so whatever. All right, IN. Will you try that on your own? IN is indium. It is right here. So looking at your table, tell your partner which one of these best describes IN. All right, I heard one person say something. What do we think? I hear A and I hear D. B? B? I hear A, B, and D. So I go to IN, and it is right here. It reacts with acid only. You probably said B when I said I thought I heard D. They're close. All right, so that was correct, B. All right, thumbs up if you can answer the next 6 of those, or the next 4. Okay, so I'll leave you with that. We kind of talked about this. Let's look real quick so we can be through 20. Use the symbol of the elements to complete the following chart. In family 1, which is the most reactive. So I just go to my table, whoops, and it's right there, FR. All right, least reactive. It's really lithium, but if you put hydrogen, I won't mark you wrong. It's lithium because hydrogen is sort of not really there, just whatever. Okay, now, those are not hard. You just look at the table. All right, but notice these two right here, these 2 columns, they're talking about the periods. So that's the side to side. And it says metals only and nonmetals, because we don't compare metals to nonmetals when we talk about the reactivity trends. Okay, so try and see. You have 3 or 4 more minutes. See if you can get through 1 through 20 based on that chart right there and your reactivity arrows. Lower lefter, higher righter. Yep, so which period does it say? Period 6. So that means 1, 2, 3, 4, 5, 6. And it says metals, right? So it would be over here. Or does it say most reactive? Most reactive. Okay, sorry, then it's cesium. Most is CS, least would be PO. Thank you. Yep. All right, hopefully you feel all right about that. Okay, so you may have already turned it off, but we'll just add this quick part. So when we did the lab today, just so you can see how it was done, I figured I'd set this up and just record a little bit. So I'm just going to put all these drops, and as you will look, you'll see it backwards, but that's okay. So what we're doing here is we're going to create a situation where a reaction can happen in a controlled environment. So I'm putting in NaCl. I just put some starch, Ki. That was in the wrong spot, but you can't see, so it won't even really matter. All right, NaBr, I'm going to put right there. Let's see, I need my NaF. Put that right there. And sodium iodide, I put right here. And then the Ki, I put in the wrong spot. It's supposed to be, the dye was supposed to go here, which I put up top, but whatever. We'll put that there. Okay. Then what we do is we add, that doesn't look right. So let me make sure I can get a different one. So I have bleach in the middle. I'm going to add hydrochloric acid, and that's going to create the chlorine gas that will cause this reaction to happen. So I'll just go ahead and put that into the bleach, and then I'll cap it. And you can see, hopefully it won't take too long on video, you can see the things at the top are starting to change color. So the NaI, this remember is Ki, I just have it in the wrong spot. And then the NaBr are starting to change colors. The dye right here will start to change colors as well. So we'll just leave that for a tiny bit and we'll see. So what is happening in this reaction is chlorine gas is trapped inside this little device, and it is going around and trying to interact with each droplet. If the chlorine gas is more reactive than what's in the droplet, then the droplet will change color. So if we look real quick, we can see my NABR, and I know that's hard probably for you to see, and then my KI and my NAI have changed, but my NAF and my NaCl have stayed clear. My dye was just to determine if the reaction has gone forward or not. So what we can learn from this data, chlorine cannot replace fluorine. So we would learn from this data that fluorine is more reactive than chlorine. Here we have NABR. It did change. So we can learn that chlorine is more reactive than bromine. Over here, both of these have iodine in them. Oh, they just collided to make a giant mess, but it's okay. The chlorine was able to react with these, so that would prove that chlorine is more reactive than the iodine. So let me just scoot this out of the way now. Well, that's a big mess. Let me just write it with a pencil. So give me a second. So we now, just based on data, can see the following information. Oh, that made a big mess. We can see, oh, you won't even be able to see it anyway. Whatever, we'll be all right. So we can tell that fluorine is the most reactive, iodine is the least reactive. So for non-metals, our arrow would point up. Let me share the screen again. And like, I'm sure we already said this in the video, and most likely you're not even watching this, but, oh, I'm on the wrong, oh, come on, Tom, you can do it. All right, so just one last 30-second piece here. So over here, we did our data to prove that in family 7, fluorine, most reactive, iodine, least reactive, so our arrow would point up. All right, hopefully that was helpful, and we'll just go ahead and end.